Hey everybody, I'm about to do several videos on something called confidence intervals. There are going to be different types that we do. And so in those videos, I'm going to get into the details of how you compute them and the different meanings and when they're appropriate to use and that sort of stuff. But I want to just get the idea of confidence intervals in general, because they can seem a little bit complicated, but when we boil it down, the same thing is happening over and over again, just different details each time. And it's a relatively straightforward idea, I think. So confidence intervals, the idea here is we are trying to estimate a parameter, right? So for instance, we might be trying to estimate a mean, right? So remember what a parameter is? It's some number that characterizes something about a population. So for instance, if I was trying to estimate how much Seattle residents, how much they spend on coffee, right? So I want to know if I looked at every single person in Seattle and took the average amount of, let's say coffee per day or something like that. If I surveyed everybody and found all the amounts people spend per day and then averaged over the whole population of Seattle, that would be the population mean, right? I probably can't do that though. Okay, so how do we estimate something like that when we don't have access to everybody, right? So the simplest way to estimate is with what we call a point estimate. This is with a single number. So for instance, let me just put up here, this is our population mean. We could estimate the population mean with the sample mean, right? So, which we usually call lowercase x bar. Okay, so it doesn't have to be means, right? I want to make that clear. I'm just using this as an example, and this is one of the big ones we'll do, but you could be interested in a population standard deviation, a population proportion, any sort of number you can compute about a population, you might want to know it. And then you would do the same thing to the sample, right? And we hope when we get a point estimate that it's close to the population mean. That's what we hope, right? Well, there's a lot of questions you might ask. If I told you that I'm estimating that people spend $4 per day, right? You might, let's say I told you that I estimate people spend about $4 per day, and somebody else told you, well, they estimate that people spend about $4.25 per day. So both of us went out and got a sample, created an average, and ours are different, okay? Well, a question we might have is exactly what did we do to sample, right? If I asked 4 neighbors, right? So I just casually asked 4 neighbors on my street, and I got a mean of $4 per day. And let's say somebody else, like a coffee company, surveyed 1,000 Seattle residents by phone, and they found, I don't know, something like $4.17, right? Well, it's pretty clear that these two estimates are not created equal, right? I would have a lot more confidence in this number than I would have in the $4 because I just went and asked 4 people. We've seen that larger sample sizes tend to give us better measurements and things like that. So we want to capture this idea so that when we make a point estimate or any kind of estimate, we don't just get the number, we get an idea. We want to capture, like, how much more confident are we in this number, right? How much more reasonable is it? How close do we expect it to actually be to the true mean? So we're going to try to pull those characteristics into our computation. And what we're going to do is, instead of doing a point estimate, we're going to make an interval estimate. Okay. And the way an interval estimate works is you start, let's try this on a number line, right? So here's a number line. Let's stick with the coffee example. This might this number line represents all the possible dollar values that the actual average numbers money spent on coffee per day is. We went out and got a sample mean. Okay, we're going to create an interval by going some distance below and above it, and that distance we're going to call our error, our margin of error, our error bound on the mean. There's different words for this, but it's just some kind of error. They're all the same thing. They're computed the same way, just different people have different vocabulary for it. And so once you compute the error, you start with your point estimate and you go that far below it. I'll use E, or actually I'll use EBM. And right? So for instance, if I did this $4 estimate and I found my error to be, let's say, 65 cents, then I would take $4 minus 65 cents, gives me $3.35, and then $4 plus 65 cents. And I would give you the interval, right? 3.35 to 4.65, right? And I would suggest that my estimate for the mean is that it's between these two numbers. This is what the interval is going to do for us. But when we give these intervals, we're also going to give how confident we are that we're actually accurate, right? And so that's where this EBM comes in. Calculating the EBM will take into account our confidence level, which we often call CL, or some people call it just C, and it will take into account the sample size, right? In this example, we said, this feels like a better estimate because of the sample size than this one, and when we calculate the EBM, it will take into account the fact that larger sample sizes tend to give us better estimates. It will pull that in, right? So again, we're not going into the details right now, but all of our confidence intervals are going to be built this way. A point estimate, we add and subtract an error to get an interval. That error will take into account how confident we are and how big the sample is, okay? The bigger our sample, the better our estimate. That will shrink our confidence interval, right? If we take larger samples, we expect to be closer, right? If I wanted to know the average height of students in my class and I asked one of them, I don't expect to be that close to the average. If I asked everybody but one person, I would be very close to the average because I'd almost be computing exactly the average. There's just one more person left. And unless that person was extremely tall or short, it's not going to affect that average very much, right? And even if they are very tall or very short, if we've already averaged 60 students, one more isn't going to change the average very much, right? So the larger the sample size, the smaller that interval. We get closer, a better approximation. On the other hand, to be more confident, the interval becomes larger, right? If I was looking at a jar of jelly beans and trying to guess how many were in it, right? If I guessed, well, it's between 5 and 510, that's a pretty precise estimate, right? It's a small interval. If I've got a jelly bean with hundreds in it, it'd be hard to be very confident, right? I wouldn't want to bet thousands of dollars on that. On the other hand, if I said, I think there's somewhere between 0 and 1 billion jelly beans in there, I would definitely bet you $1,000 that I'm correct, right? If there's a jar in there, between 0 and 1 billion is such a wide interval, I'm almost surely correct, unless it's some massive jar. And so we have high confidence, but obviously it's not a very good estimate because between 0 and 1 billion is not precise at all. So this confidence level is like a trade-off. We can be more confident, but less precise, right? So we'll see all the details of that. But what I really want to focus on is this idea that we're going to do, we're going to have point estimate, an error, and then our interval is just going to be the point estimate, let's just say it as the point estimate, plus or minus the error, right? And that's how we build these. And most of the work is going to be done in here. How do we compute this error bound? Okay, so I'll do some videos on the details of this. We're going to learn several different kinds of, there's different approaches depending on the situation, how you compute this, but they're all very, very similar. But we'll do that in later videos. All right, that's it for this one. Thanks, everybody. I will see you next time.